This is Digital Spaceport, and today we are going to be building an exciting computer together. We are going to be building the AMD Threadripper Pro 7995WX inside of our Fractal Define Meshify XL2. This case has been tried and true, and I've actually had to fall back to it because this just offers the right size for this motherboard. We're going to be utilizing the ASUS WRX90. This is a professional grade motherboard. We're also going to be including a 4090 256 gigabytes of insanely fast RAM, and we're also going to be seeing what we can hit as far as speeds on some T705 NVMe's. I hope you're excited. I know I am. Let's jump in. Let's unbox the Pro WRX90E Sage. This is our workstation motherboard that we're going to be using. So in here we have two nice 8-pin power cables. And we have a dual Y cable for the ATX power. The motherboard itself, we'll get to that in a second. We have our ASUS Control Center Express license card, warranty, and manuals. As far as cables, we have a thermistor so that we can record temperatures. Looks like 2 of these Thunderbolt pass-through cables, 4 SATA cables, mystery little bumper things, power adapter, I always like that, mystery rubber thing, retaining screws for the M.2s, another footer thing, and oh, one of those M.2 screws it looks like. So that's what's inside here. Let's take a look at the board. This board is very heavy, which is one of the reasons why I opted to not risk trying it out in a different setup as far as cases, because this is very, very heavy, and I don't want to have anything happen where there's a flexing on it that could hit something on the back. It's all got plastic wrap on it, so be sure to take this off before it gets hot. On the back side, protective film on it, so make sure you remove that also. And there it is. And so powering this build is going to be a Seasonic PX 1600. This is a great PSU, and let's take a look at what all is included in this box. Always good to give me Velcro. Manuals. Feels like a gigantic bag of cables. PCIe cables and some SATA cables. PSU tester. Power cord. Oh wow, that is a lot of cables that we have here. And I also like that they include braids so that we can easily bunch these up and have them stay looking good. Now let's get the PSU out. Oh, that's heavy. And you can see that we clearly have a pretty demanding plug type. So this is capable of using a tremendous amount of electric, but for something like a 7995WX build, you might consider something in the 1600 class. I would even consider going higher if I would have been able to find it. I also like that there are so many plugs that we have up here. They really managed to utilize this space to the maximum, which sometimes I feel like they might not on certain PSU manufacturers. So this is our GTX 4090 that's going to be going into this build, one of 2, but definitely this one will fit. I'm a little bit sketchy. We're going to try one first before we actually look at putting 2 in, just to see what the wattage is like. I don't want to run into a situation where it's marginally okay, especially with something that draws this much power. And of course, the 4090 has 2 HDMIs. These are the things you have to buy nowadays to get 2 HDMI slots, apparently. Wow. That is a tremendously sized GPU. A Republic of Gamers card, warranty, graphics card holder stand, which that I hope is in there somewhere else. I don't see it quite here. Discount, some useful information if you're new to a 4090 about how to not burn it up or the rest of your system. Quick start guide, and I guess this is a little stand you could put together. A couple of Velcros and your stand. Hopefully keep this from sagging. We've got our 1 to 4 breakout cable so that we can power this with normal PCIe power supplies. Booyah! Next, we're going to be getting into the T705. This is a 4 terabyte unit that has a heatsink included. Not sure if I'm going to keep that on or replace that, but this should be able to hit somewhere in the neighborhood of 14 gigabytes. So this is a pretty exciting NVMe to hit that class of performance at a price point that is pretty decent. This is the second release. There was the T700 from the first generation. So this is a small little 2280. Really buried down in here. This heatsink looks pretty sizable, but it may not even be close enough if you're putting a lot of stress on it. Let's check out the RAM option for what we're going to be using. This is the G.SKILL Zeta R5 Neo. I actually have 2 kits, and they do actually warn you that the kits are independently matched. However, I think that's going to be okay because I'm not going to be pushing the overclocking of the profiles as hard as possible. I'm going to definitely be backing it down some. And I also saw that there was a couple of good tips about starting out with the first DIMM slot and then populating the rest of the DIMM slots after that for people that were running into issues with this particular RAM on the WRX 90. Of course, V-Color is another option out there, but I went with the G.SKILL, and we're going to see whether or not we can get it even close to 6400. Oh man. You know you've got some serious RAM when it comes in a box like this. It's crazy. It's not terribly flashy at all, but performance is what we're after here. And let's hope that it does really good on that front. And we're going to be using air cooling for this build as we're not going to be overclocking the CPU yet. Before we get there, there's several other things, especially case and power, that need to change. But we're going to start out with the NHD9 TR5 SP6 4U CPU cooler. We also have the 14 from the Noctua line that we can test against also, but I like the orientation of this one a little bit better for how it's going to evacuate the heat. This should be a pretty big heat sink that this has attached to it. And we're actually going to add in one extra Noctua fan to the back so that we have a triple fan setup. It has pre-applied thermal conductive interface. It also comes with the Allen wrench and a 1 to 2 breakout cable. And we're going to be adding a 92mm fan, the NF-A9 from Noctua. And we've got some extenders, as well as some breakout cables, case mount fans, and rubber grommets. But we're actually going to be using some retainers that I bought to turn this into a triple fan. Powering our insane build is going to be 17995WX. Threadripper Pro, this is a beast. We're going to have a lot of fun with this processor. Whew. I got chills just cutting that. Oh, this is so packed with goodness. This is so packed with goodness inside. Give me a nice, tiny Threadripper Pro sticker. Thought I got a bigger Threadripper Pro sticker last time, but I guess they've downsized their stickers. Oh, great. This is awesome. So it looks like they did give me some tools that you might not expect. Got a mounting bracket for an AIO cooler. Now, there are several AIO coolers that are listed as being compatible. I might end up there, but I'm going to start out on air cooling. And we also got our torque screw here. And so this will break whenever we actually get the appropriate tightness on it. Simply insane. This is going to be so wild. So much power. So much PCIe. This is going to be a wild ride. I can't wait for us to press that power button together. And one of the nice things about this case is that you can fully deconstruct it. Well, pretty close to fully deconstruct it. You can deconstruct it so much that it makes it very easy to do things like placing the motherboard in here. I'm going to check which standoffs need to be placed. There's some extra ones that do not need to be placed that make the actual end row on the WRX90 incredibly important for the support of the main board overall, because it skips the, I think it's third row in the ATX standard, essentially on half of it because it's got a giant backplane covering it. Let's take a look at those. It's incredibly important to get a motherboard tray that is adequately sized, or else you will definitely have problems getting the support that you need for this heavy of a board. Let's take a look at this more in depth. So as you can see, we've got the 4 holes that we have for mounting down here. Second ATX, third final ATX, and then we are over into the SSI realms over there. And you can see that we have in the second column here, another one here. We skip the third column and it goes all the way to the SSB column over there. Then we come up here, we're not having one underneath the RAM, of course. We've only got one support here and one support here. And if you look over here, you can see that we've only got one support in this upper corner. So this is why it's important for this motherboard in particular, which is a incredibly heavy motherboard, to get a good fit for the chassis. If you look here, you can see kind of how much room's left here on the edge, and it's not terribly a lot at all. So this is why I wasn't able to get this into several other cases, and I'm ending up going back to my standby case that just seems to always pull through because it is so large and it can accommodate almost any motherboard size. All right, now let's go ahead and get the motherboard installed. Next, we're going to go ahead and get the processor installed. Next, we're gonna go ahead and install our Noctua cooler here. I've got a front fan and a back fan that we'll be adding on to this as well. I need to have those off to access the mounting screws here. And it does come pre-applied with, I'm gonna assume and hope, some incredibly good thermal paste. So let's see if we can get this off here without, here we go. Take a look at that RAM clearance. It looks like it won't be an issue here. So I think I'm gonna go ahead before I put these final fans on and plug in the power unit because there's a pretty close proximity here. Once I have that fan installed, there won't be a ton of finger room to get in there. So I'm gonna install that, and I'm also gonna install the NVMe now. While the Crucial T705 came with a cooler for the same price as the unit without a cooler, and it was on sale right now, I do like the actual massive size. This entire piece of aluminum here is the heat sink, and it's got really good airflow channeling in this direction. And there's, you know, there's fans right here also drawing into that. So I think I'm actually going to take this out of the case, even though this is a very nice case, and I can use this certainly in something else on a higher temperature NVMe. And I'm contemplating changing these thermal pads out for custom ones. Let me know what you think about that in the comments below. And the Seasonic Prime PX 1600 is definitely a heavy-duty PSU. It's got the 20 amp plug on it for that reason, and it's also on this motherboard. This motherboard can actually facilitate running dual PSUs, so that gives me some great ideas for what I might be doing in the future. 3200 watts. Oh, wow. That could fit quad 4090s into it. We're talking either 30 amp dedicated circuit with probably 245 VAC. I've got that running in the garage, so that might not be that hard. But this is a really nice PSU. They did a good job of giving you a ton of cables, and from what I can tell, it would be able to fit most scenarios for most people that are doing anything even slightly normal. Now, I will say it is expensive, but Seasonic is known for having long life, and I really do hope that that pans out here. Cabling. I really am not great at cabling, but don't judge me on that. We will get it done, and that's kind of going to be what matters here. It's not going to be the most beautiful cabling job that you've ever seen in your life. I try, but definitely this case does give you a lot of points to jam cables in, hide cables, so it does make it kind of easy, even for somebody who's bad at cabling clean, like I am, to do a decent enough job. And I am kind of nervous about the heat sink that I've picked here. Dual 92 millimeter fins and 3 fans. Now I also have the NH-U14S. That's a 140 millimeter Noctua that we'll try out at some point also. This has front to back airflow. The other one that we'll try out later has bottom to top airflow. And you know, I think it'll just be something that'll be interesting to see. I've used it on 64-core CPUs in the past, but they're epic, so they don't really overclock. This overclocks. But the whole thing eventually goes water cooling at some point. I'm pretty convinced that I'm going to end up water cooling it. All right, and we got it put together here. Like, very, very few things left to do on this build for us to call it done. And as an air-cooled build, it'll be interesting to see how noisy it is. I'm going to guess it's going to be kind of loud. I think that it's going to have a ton of heat that it's generating. And the 4090 will definitely be contributing to that heat load also. And it's also, speaking of loads, quite heavy. So I am really glad that this came with the little prop stand. I would be interested if anybody knows of any custom makers of brackets so you could fit 2. I tried fitting 2 in. You can fit 2 in, but you need to have some spacers that are
kind of custom made, in my opinion. And this is good for one, but it's not good for the lower side if you wanted to have two in there. Oh, it's looking good. Last things that we got to do, put the case covers on and give it some testing.
So we've got it all put together here. I did actually go ahead and take off the symmetrical multi-threading. It was definitely running too hot. So that's one thing to consider. This is a hot CPU chip. If you're going to be doing any processing on it at, you know, high frequencies, you're probably going to want to get water cooling is where I'm at this moment. I've got another heatsink that we can try on here that worked on the SP3 Epics that I have. We'll see. It probably is a little bit bigger, whether or not it's better. This has two 92mm fins on it, which is pretty big, and 3 fans. The other one just has one gigantic fin. You can see it behind me there, and that's the Noctua U14S, I believe. And so we'll see whether or not that can do a better job of cooling. I went ahead and already installed just a Windows 11 workstation. Again, workstation probably is a little bit better possibly for you if you're looking for doing things like RDMA and also if you want RefFS. So those are some things that I've already done. Let's dive in and take a look at just some quick benchmarks. I don't have very, you know, complex benchmarking for you guys. Sound off in the comments below and let me know what you want to see. I would definitely say game benchmarks would not be what I would expect to use this system for. Playing video games is definitely going to be something much cheaper to do on a desktop system. This is really all about accessing tons of PCIe lanes. This could be an ultimate virtualization host. This could literally host all the virtual machines that I would probably need. However, I do believe in having a redundant cluster, so there would have to be some trade-offs and some considerations around that. Let's dive in and get on the desktop and see what we can do as far as some just benchmarks that I was able to find out there. So we're going to be running Cinebench 2024 here. I'm running the CPU multi-core first, and I'm also recording on OBS at the same time, which of course is not ideal. You can see the score that I got above 3634, and we're at about 3582. Looks like it's kind of bouncing up and down, but we'll see where this one ends up. And then we'll run the single, and we'll also run the GPU test off of this. And we're just under what we had scored the other run, but well over double what the Apple M1 Ultra. Let's run the single core here. And this is definitely not ideal to run at the same time that you're recording on OBS, but you can see the prior score that we had was 111, 113 was the Apple M1 Ultra and Max both. And landing at 110, we're just 1 point off from where we were last time. So let's go ahead and run the GPU test also. And this one, at least we don't have to wait very long for. You can see the prior score was 27071. And we should be right around that. Yeah, just a little bit under that at 26402. And in case you're wondering, I do actually run 8K. I have a TV, a Samsung TV that is an 8K TV. That is the 900A. You can find a link to that in the description below. It is actually a pretty darn good television for 8K 60, or you can do 4K at 120. And these oftentimes can be found for pretty decent prices. But yeah, I do run 8K on this monitor at 250% scale. What is next here for testing? So this is kind of interesting. We have Docker Desktop, which is just the application. And inside that we have a open web UI. Let's see if I can get the task manager pulled up so we can see if we're using GPU or CPU or exactly what we're using for this as we run these different models. So I've got the 8B selected here, and I'm just going to give it a quick howdy to warm it up and get it loaded. And we'll check the tokens per second, which is a good way of seeing where your application's at. And we can see already that it's looking pretty fast actually. So 60 tokens per second, it did look like that didn't hit the CPU really, and it was able to live inside the 4090, which great. And it does look like, yeah, that is eating a lot of the dedicated GPU memory, but looks like it's able to fit in there. Impressed by that. Let me ask it to tell me a quick story about a cat in 4,000 words. All right, and it's whipping it out there pretty decent, and we'll see whether or not it's actually going to get close to that and what the tokens per second look like if it's able to hold up. And you can definitely see it's churning 94, 96% utilization on the GPU right now. So that is running very efficiently inside the GPU. It looks like it may be, well, that might just be one single thread that's going on. That might make sense to happen no matter what on the CPU. But this is pretty cool. This is pretty fast, and I think most people that are using Windows could expect to have similar results. That probably is about 4,000 words also. And that was at 49.63 tokens per second. Fairly decent. And for Windows versus Linux, make sure you follow some of the prior guides on setting up LLAMA and also some benchmarking that we did. This is not really going to be that benchmarking because it would need to be a Linux installation, and we will have a separate, I can already tell you, I'm thinking very, very strongly about putting this onto one of those racks and putting 2 PSUs on it. Once that got into my mind, I've just kind of embraced it a little more than I should have possibly. But it seems like a really good way to get some water cooling running on it also and get 4 4090s. And I would be very excited to see what 4 4090s would be able to do. So I guess that tells us what we need to know about that. Now let's go to a model that will definitely not fit in VRAM. That's the 3.170B. You're looking at 4 24 gigabyte GPUs to run this at the quant that you would be able to get. And so I'm going to give it another howdy here, and that should unload and reload the model, the 8B out of RAM, and whatever type of sharding happens in Windows. I know it does do layers in Linux, so it'll fit what it can in the GPU, and the rest of it goes to system RAM. We can see the system RAM growing quite a bit here, so that might explain what's happening. I think that probably is what's happening here. And you'll see a significant reduction in speed as a result of that. You can see the CPU starting to spike up there also, and it just died out on us, unfortunately. I'm gonna go ahead and hit the stop on this because it would be unacceptably slow even if it were to process, and for sure we won't be able to load up the larger 405B in this either as a result of that. However, I can load up and run the 405 also off of system, RAM, and CPU, but at a very, very slow speed on a prior generation EPYC. So that is something that should work here also, but we'd need to be over in Linux. I think I can just pop that over. I'm not going to do that this time, but maybe next time I'll do that. So let's go ahead and run a CrystalDisk mark, and just so you can see, I have it set to the NVMe SSD default settings, and the profile that I typically use for this testing is peak performance. I've got 5 iterations of 8 gigabyte file, and we have about 42% of our C drive, which the C drive is again the super fast crucial T705 4 terabyte NVMe Gen5. Let's give this a run. And as we can see, we're at 14 gigabytes a second for reads and 12.6 gigabytes per second for writes. Now that's sequential with Q8 and thread 1. We could, of course, adjust those queues, but we're not going to really get anywhere faster by doing that. Check out Q32 here, thread 16. You can see that we're about 5.1 gigabytes per second and about 2.7 for the writes. However, this one is definitely probably the most important. The RAND 4K IOPS is insanely good, and that is just insanely good. So that is 1.259 million, it looks like, and $675,000 for right. That is really nice. I don't know what is considered good here, so I'll just hope that that's good, and you tell me in the comments below whether or not that is. So my biggest takeaway is that if you are looking for this for almost 95% of tasks, you'd be much better off going with either one of the lower line or just going with the highest end desktop that you could get. But this is definitely, if you need to have lots of GPUs and if you're interested in doing things like training, going to have a benefit because of the multiple PCIe lanes that are going to be accessible at Gen 5 speeds. And this is insanely fast numbers of memory channels that we've got also, providing massive amounts of RAM bandwidth. But as we can see, the benchmarks weren't really blowing anything away. I think that we're still running into thermal issues here as well. So definitely going to be looking at water cooling to get this up faster. I've seen some benchmarks that other folks have done that are just like, wow. Of course, also, I need to get Linux on here as well to do some real benchmarking with things like Phoronix Test Suite, which will be able to run quite a few benchmarks. So I hope you guys have enjoyed this. Let me know, like I said, in the comments below what you would like to see benchmarked on this machine or on the Quad 3090 GPU machine. I can definitely see that this would be an awesome unit to have in one of the racks, like I've got the Quad 3090s in. I'm very, very seriously considering that. So either talk me out of that or talk me into that in the comments below. Everybody have a great one, and I'll see you guys next time.